In this video, I want to show you a couple ways we can look at right triangles. There is not just one way to solve a right triangle, and so we're going to discuss all the possibilities for this right triangle. So if you're looking at the one on my screen, I see that I have a 60, I see that I have a 10, I see that I have an X and a Y. So let's talk about some of these things. First, I notice that the A is an angle, so I could put my theta there, and then I could label my triangle, opposite, hypotenuse, and adjacent. The problem is I don't know two of my sides. I only know the hypotenuse, so I couldn't use sine, cosine, or tangent to figure out what A is going to be. Instead, I know that a triangle has to add up to 180 degrees. So I know one of my angles is 60. I know I have a 90-degree angle. And I know that there's A in that top corner. And every triangle has to add up to 180 degrees. So I could use this to figure out what that missing angle is. Turns out that missing angle is 30. So I know that that top angle is 30. I could look at this triangle and realize that, gotta find my eraser here. I could look at this triangle and figure out that, hey, I recognize this triangle. It's a 30, 60, 90 triangle. So I could recognize that this is a special right triangle. Everybody's favorite type of triangle. If I know this is a 30, 60, 90 triangle, I didn't even have to use what I knew about 180. I just am recognizing a pattern and going from there. Well, if this is a 30, 60, 90 triangle, then I could label it hypotenuse, short leg, because it's across from the 30 degrees, and long leg. And if I know it's short, long, and hypotenuse, I can use my special right triangles to determine how long those sides are. Well, there are two rules for 30, 60, 90. The first one is that your hypotenuse equals your short leg times 2. Well, I know my hypotenuse is 10, so my short leg must be 5. The other rule I know is that my long leg equals my short leg times the square root of 3. Well, if I know my short leg is 5, I know my long leg is 5 square root of 3. Could I have solved this another way? I certainly could. Looking at my triangle, I have a 60. So I could put my theta down there and then label my triangle opposite, hypotenuse, and adjacent. I could set up trig ratio. If I use opposite and hypotenuse, that would be sine 60 degrees equals x over 10. I could set up a cosine relationship, 60, and that would be using my adjacent and my hypotenuse, y over 10. Once I found those sides, I could most certainly use trig ratios to find A as well. So there's not necessarily one way to solve a right triangle. There could be multiple ways. And in the exit ticket, which you'll find on Google Classroom, it will ask you, here's a picture, which of the following could be ways to find what we're looking for. And you'll have to determine if you can use Pythagorean theorem, trig, special right triangles. Maybe there's a combination and you can use more than one. So go check it out in Google Classroom.